Biologist, we had a PhD linguist to make sure we had the right wording, combustion theory, thermodynamics, mathematics education, and computer science. That's a pretty diverse group for a whole week, and we liked each other. You know, the amazing thing was, you know how we started every day? Reading from the Bible and prayer. We just thank God every day. I love running forums like this. So here was our 4 attributes. The goal was to develop a universal definition using those 4 attributes. And here's our definition we came up with. An encoded, symbolically represented message conveying expected action and intended purpose. That was the definition we came up with. What we did was we went and found the characteristics and then put them in a sentence. That's basically what we did. And we're going to have to evaluate this now. And then we're going to see the power of this definition. So there's the definition again. An encoded, symbolically represented message conveying expected action and intended purpose. 4 attributes. What do we mean by encode? Simply a code, like the alphabet. Symbolic representation means it has meaning, like the word chair represents or means something real. Expected action means action, intended purpose meant purpose. So all we did was take the 4 attributes and put them into a sentence. Now we have to see, does this work anywhere? We have the definition, but does it really work everywhere? Let's take a look. We saw it work for the grocery store. Go to the grocery store and buy some chocolate chips that had a code, meaning, expected action, intended purpose. The code was the word, the meaning was store represents something physical, doesn't it? Expected action, somebody would go to the store and buy some chocolate chips. Intended purpose was somebody would go to the store, buy chocolate chips, and make cookies. Now let's take another sentence. How about in the beginning, God created the heaven and the earth? Does that meet our definition? Well, how about code? It uses an alphabet, doesn't it? So it has a code. Does it have meaning? Yes, it does. God represents something real. The heaven represents something real. Earth represents something real. So the words have meaning. Does it have an expected action? Yes, it's called creation. And then the intended purpose, which is implied there, is for the glory of God. His creation is for his own glory. The heavens declare the glory of God. So when we look at the Bible, we see what? It does meet our universal definition. So what we find in the Bible is what? Information. And that information came from where? God. He gave us his information. So now let's examine this definition scientifically. When we look at science, we have things called theories, models, hypotheses, and assumptions. Where do they come from? Well, we make them, don't we? We originate theories, hypotheses, and assumptions, and we formulate ideas about them. So we originate them and we formulate ideas. But above that level of science, there's a very large gap. A large gap in science. Because what's above all of those theories, assumptions, and models is something called scientific laws. Now look at the difference here. We discover scientific laws and we formulate ideas. We don't create them. We can create hypotheses, we can create models and theories, but we do not create scientific laws. We discover them and formulate ideas. So where'd they come from? Starting to see a little mystery in here. We're building our way up there. Remember our 2 goals. Refute materialism and show there has to be an all-knowing, all-powerful creator God. So what are scientific laws then if we don't invent them? Precise statements formulated by discoveries through observation and experiment. In other words, we discover them that have been repeatedly verified and never contradicted. Then it can become a scientific law. Let's look at some. We have scientific laws about matter. Newton's law of gravity, laws of thermodynamics, laws of electricity, and many others. So we have many laws of science about matter. We have a law of science about life, that life only comes from life, the law of biogenesis, which is, you know, we have that law, life only comes from life, biogenesis, but every single biology textbook ignores that. Isn't that amazing? But we also have laws about information. So let's look at some of these. Why are scientific laws so important? Well, they're very important. See, without scientific laws, we might not have things like cars, computers, microwaves, and here's the most important, hair dryers. Boy, we couldn't live without those, could we? And many other inventions. Without these laws of science, things wouldn't work the same all the time, would they? It would all be like random chance events. Someday your car might work, someday it might not work. You might have cars like that already, but that's a whole nother talk. So scientific laws are very important for how we live. Now, I'm going to take a look at some of these scientific laws. I'm going to look at 3 general scientific laws. Then I want to show you 2 scientific laws about information. And we're still building our case. Like I said, don't blink. This case builds and builds. Scientific law number 1. Something material cannot create something non-material. Kind of makes sense when you look at it. Material things are mass and energy. Non-materials are things like thought and spirit. Something material cannot create something non-material. When was the last time any of you made an angel? Okay, we can't do that. Scientific law number 2. Information is non-material fundamental entity and not a property of matter. What? There's something we don't normally see. Information is non-material. It's not a property of matter. In other words, we can take a look at the information in a book or in DNA, but we can take that information and put it in many different types of mediums, can't we? I can send the same information I write in a book by smoke signals. I can put it on a computer. I can put it in your information in your DNA. We can record that in many other types of matter too, can't we? So information is not dependent upon the matter, but it needs something material to reside. So that's scientific law number 2. Let's take a look. A hard drive stores information, but the hard drive is not the information, is it? The information is encoded onto the hard drive. Likewise, a book stores words, but the book is not the information. And the paper is not the information. Information has been encoded onto this material resource. Let me give you a good example here. I take a balance scale here. And I take an empty CD, a modern CD, and I weigh it. Then I write the entire encyclopedia and the Bible onto that CD and weigh it again. And guess what? They weigh the same. In other words, information has no mass. Now, I want to remind you something. What was one of our challenges? That we cannot defend against materialism, which means all that exists is what? Mass and energy. Are you starting to see something very unique about information here? It has no mass. Because if something exists that is not material, that means the whole philosophy of materialism, which includes atheism, secular humanism, and evolution, are false. Now, our scientific law 3, the first law of thermodynamics. We have to do this a little bit. You know why I have to bring physics into this? Because physics is fun. How many like physics? You know why you like physics? Because it's in the Bible. Romans 8, 20 through 22 is a general description of the second law of thermodynamics. Now, how many like physics? If you like the Bible, you like physics. Okay, because physics is fun. I like that. Now, mass and energy. First law, mass and energy can neither be created nor destroyed. All mass and energy in the universe is being conserved. The total sum is constant. Now, they might be able to change forms, but the total sum is constant. Let me show you something very exciting here about information. I can go to the whiteboard and create a brand new mathematical formula, which is information. Notice I said create it. And then I can take an eraser and erase it. You know what I just did? Destroyed information. Now, wait a minute. I thought the first law of thermodynamics says you cannot create nor destroy mass or energy. But I can create and destroy information. Does that kind of give us a clue? Maybe information is not material? Is that important? Yes, it's going to be very important here. Hubert Yockey, PhD in physics and information theory, wrote a book called Information Theory, Evolution, the Origin of Life. Now, Hubert Yockey is an evolutionist, but look what he has to say. The genetic information system is the software of life, and like the symbols in a computer, it is purely symbolic and independent of its environment. Of course, the genetic message, when expressed as a sequence of symbols, is, what's that word? Non-material, but must be recorded in matter and energy. Right there,